Sergey and the folks at Meta especially, but also IBM, other companies are spending a whole lot of time on reliability, observability, the ability to maintain Prestissimo clusters. So I think there's just a tremendous amount of work going on in this area, and it's super important work. What we want to do though is we want to make C++ clusters the default. So there's like a huge opportunity cost for maintaining a split Java and C++ eval. And we've just kind of like been, basically eating that cost for the past few years. So what I want to talk about is, a move towards, what does it take to get to general C++ availability and some of the things that we're thinking about to get there. I think right about now slides would be helpful. Is there like settings or something I can?
Yeah, maybe display settings.
Let's see. Maybe I can use someone else's laptop and I can send this to you like that. Okay, yeah, I'll Slack you. All right, copy link. Sure. Let me. Let's see. Make a copy because for whatever reason I can't get a shareable link here. So let's. Send this to you, Sergey.
It's like my laptop.
Yeah, we tried USB-C in the display port. Yeah, it doesn't work. So did you get it? I sent it on Presto DB Slack.
Okay. Yep.
Got it.
So, yeah.
Oh, that's okay. Wonderful. Thank you. Let's give a round of applause for the AV folks. Okay, great. So I'll come back to where I started. So what we would like to do is make C++ the default. So there's a bunch of obvious reasons for this. Like we see tremendous performance improvements and cost reduction with C++. Sergey, like we keep talking about this, and there's just a very deep desire to make it cheaper to operate Presto in a data lake. And that's only going to get more and more intense over time. A secondary reason is with a common core eval, we think that we can move faster in the open source ecosystem. So what we can't do right now in the closed Presto ecosystem is leverage Spark's iceberg changes. But with a common core eval, Spark and Presto and other communities can build the same code to let's say access iceberg data or share functions in a way that's just impossible without a common core eval. So I think like there's really there's many compelling reasons, but there's two very, very obvious reasons to move towards Velox, and clearly this is our strategy. But I think like it's not said very often, but there are also less obvious reasons. So the first, and I kind of alluded to this before the slides came up, but I think the first reason is we've made this decision, I think, a few years ago, and since we made that decision, effectively, Java eval has been defunded. And so, there's an opportunity cost problem related to that because any developer or anyone who works on Presto has to make the decision now. Do I put the change in Velox or do I put the change in Presto 2? And very often, we just don't put the change in Presto. So we need to move very quickly to get off of Java eval, and we need to relatively quickly as far as database systems go, It seems like nothing is really lightning fast, but as quick as we can, we need to start to think about how do we maintain only one copy of these so that we don't have this opportunity cost problem. So that things like, Parquet modular encryption, like new operators, like we don't really have to kind of like going through the same problems over and over again. We just do it in one place, which is the Velox community. And then I think another side benefit really is that with this decision being made, we have a really good opportunity to just delete a lot of code. The Presto project is huge, and with a common core eval, it doesn't really make sense to maintain a lot of it. And especially the eval code on the Java side is just very complicated. So we think that we can move a lot faster by just maintaining less code and focusing on integrations. So the question is, what do we do? What do we need to do to make C++ clusters the default? So there's a few things. Firstly, it needs to be reliable. So this is kind of like what Sergey was talking about. There's a tremendous effort underway, validating that Presto can be operated in a very troubling production setting. So and it's not just Meta's workload. Companies are starting to use Presto C++ in production, and we are getting a lot of really promising signals. So it needs to be reliable. It can't crash. It needs to be trustworthy in a production setting. The second is that we need to be able to administer it. So if it doesn't fail outright, we need to know what's going wrong. We need to be able to go in time and figure out how can we support these C++ clusters. So we've also made a lot of progress here because now we have observability through our Prometheus integration, and we have a lot more administration tasks that are available on Prestissimo clusters, in particular graceful shutdown. We need to make sure that C++ clusters are correct. So I think there's probably been a talk on this. You can correct me if I'm wrong, but the Velox community did something really, really smart, which is that I think early in the project, they invested a lot of work into what's called fuzzer testing. And I think fuzzer testing has really uncovered a lot of bugs prior to them going into production. And so, and I think that's starting to pay off in a very big way because, I think that the rollout has been smoother than it otherwise would be. And the proof of that is how many bugs are being raised on the Java repo on, functions that just have strange semantics in certain corner cases. But it's not just functions. I think there's many aspects to Velox fuzzer testing, and I think that this is a really huge boon to the Velox community and by extension to our migration to C++ clusters. But in addition to that, we've tested Prestissimo with all the end-to-end tests that run in our repository on every PR. We have new dedicated example-based tests. I think one thing that's missing is optimizer level fuzzing, and that's something that I think we could invest a lot in. I would like to invest on that next year. But I think that we have actually also come a long way just through the production rollouts and the testing methodology on kind of like making sure that it's generally correct. So I think and then finally, is it sufficiently functional? So does it do what we need to do? So this talk is about is it sufficiently functional? And this problem really fascinates me because I tend to like problems that I feel like are a little bit overlooked. And it's not that they're overlooked, it's just that they haven't been prioritized. So I really enjoyed this problem, and we're going to be talking about more of the functionality related aspects. I think that we've just made absolutely tremendous progress. We're not done yet, but we've made really tremendous progress on reliability, administration, and correctness. So in terms of the functionality, what's exactly missing? This isn't a complete list, but there's some big things and some little things. They could be big if they affect you. Connector support is missing in Prestissimo. So what I mean by that is that you can't drop in a project and just have it run inside of Prestissimo. You can fork Prestissimo. You can fork the Prestissimo code and add a connector, but you can't load a connector at runtime as you can in Java. So forking an open source code base versus implementing a library, those are order of magnitudes different things. And so one requires kind of like ongoing investment, maintenance of a fork. It's a very big decision. You might have the resources for that, but a lot of people don't. There's other things like, types and functions. Prestissimo strives, Velox strives to maintain the list of Java built-in functions. But what's missing is the ability to customize the built-in functions as you can in Presto. So like what you can do in Presto is you can just add another flavor of Presto. Like let's say I have a business unit. This business unit has 10 functions which allow me to do X, Y, Z. You technically can do that, but you have to duplicate. You have to write C++ and Java code. I think that there's some sort of like JSON mapping, but it's a manual mapping. So what we want is kind of like a seamless way to just drop in new functions and types. There's some functionality, I think actually Sergey alluded to this, that will just never converge. It's just because it's very, very hard for you to get the exact same Presto behavior. Just some of the examples are like array sort, regular expressions, digests, geometrical functions. I think we might work on like geospatial functions, but like in general, there's a long tail functionality, and some of this we just don't expect to converge. And I think, overall, the way that I describe this is that there's a split brain problem. So what you have in the Presto coordinator is, well, I have this list of Java functions, and I have this Java plan, and I think that this is good to go. And you don't really consult, well, what can the worker do until you start to actually execute the query. So this kind of like creates interesting situations where you might have a heavily queued cluster. You don't know that it's not going to work until it starts to execute, which could be it could be minutes, could be hours. You also don't know if you can route it. So like you don't know if it's eligible for C++ basically until you try to execute it. So you have this kind of like these late failures, which might be okay for you, but it also could be problematic. And then you could also do interesting things where like for example, you can create a table but not be able to query it or insert data into it because like you create the table with a type that Java knows about, but then you go to insert data, but like the Velox doesn't support that type. So there's this split brain problem, and the overall goal is to basically bring these things to some sort of consistency. So we'll segue this into just kind of like an overview of how does Prestissimo work. I have some charts, or I have some more detailed information in a second, but just in general, I'm not going to go through all this. Basically, Prestissimo is a facade that looks and feels like a Java worker. So basically, Prestissimo just kind of like pretends it's a Java worker and says, you give me a task to execute, and I'm going to pretend that I can do everything inside of that task, which is a pretty reasonable approach because it gets you a lot of things for free. So like the resource utilization, used for queuing, used for reporting, all just kind of like works out of the box. A lot of things really just kind of work under this approach. But it's not comprehensive. So if you take a look at this, you can buy this, but I think you can also find it online for free. If you're interested in databases, you should just read it. But I think if you look at this diagram, you can kind of like get almost the false impression that the plan executor portion, which we might call Velox, is kind of like an unrelated thing from the query write, kind of an unrelated thing from the parsing and authorization. The reality is that these are all kind of like very interconnected and interdependent. That's because when this was written, these were all one process and all one code base. And everyone who was making a database when this was written was doing it kind of like an all one monorepo. But the reality is that there's lots of interdependencies between these boxes. And so the way that this manifests in Presto, a lot of it falls along the lines of the SPI, so like the programming interface to Presto. So what do I mean by that? If you look at a Presto coordinator and a Presto worker, the big boxes represent the process, and the little processes represent all the ways that you can customize Presto. In a Java cluster, the way that these are shared is basically they just share the same code base. So the blue boxes basically use the exact same code. So on the coordinator, when I go, OK, I'm going to use QDigestAg, I know that I have a function registry of QDigestAg, and that takes in, like, let's say these certain types, and I can basically say that this query can be planned, and like we can generate code for that. And then I can create a task, and I can send it to the worker, and it's actually going to generate the code and execute the task and process splits. So just to make this clear, you have some parts of the SPI which rely on this shared code base model to function. So you have functions like you have a metadata aspect. Usually it falls along metadata lines and execution lines. Connectors, you have to get the metadata from the connectors in the coordinator, and in the worker, you actually fetch the data. Functions, you get the registry of functions in the coordinator, but then you execute the functions in the worker. But there's this reliance that these are actually the same exact thing. What happens in a Prestissimo worker, if we just use the facade-based approach, is essentially you just kind of like rip out all those blue boxes from the worker, and you just have a red box, which is just kind of like an amalgamation of what Velox supports, which may or may not overlap with those blue boxes because either we haven't implemented the functions yet, we haven't implemented the types, or you have custom functions which are not shared with, there's no re-implementation inside of the coordinator. So that's kind of like the problem. It manifests itself in a few ways. So for example, if you do show functions, you get the Java list of functions. You don't get the C++ list of functions. If you can generate plans that will basically fail, you won't know that until execution. So basically the coordinator has no right to say this is a decent query. It will just basically say looks good to me, and you don't really know that until execution starts. DDL incompatibility, I mentioned that. You can set session properties that don't take effect, that don't do anything because they only are used by the Java worker. And then you kind of have to duplicate functions between the C++ and Java workers. Right, so why do we need a native-aware SPI? You can think of an SPI like an API. It's just like a library programming interface. Presto has an aspect of a platform. It executes queries, it schedules them, it does all the databasey things. But it also has an aspect which is a library. You can make a custom flavor of Presto and just get it to do what you need to do. That's what the SPI is. Why do we need a native-aware SPI? Most users of Presto use some sort of connector. It might not be Hive, it might not be Iceberg, it could be something internal. It could be like you have an internal data source within your company, you have something that's esoteric, you have a lot of folks who use Presto use something which is not public, and that was critical to their adoption of Presto. I would argue that Presto's flexibility was key to its adoption, and so as a design decision, we don't want to drop that flexibility. We want to maintain that flexibility because people find value out of that, and that was kind of like critical for Presto to gain adoption in the first place was its flexibility. And for existing users who do use this SPI, the question that we want to solve is how do I use a Prestissimo cluster? And so we want to help folks with that and help them use Prestissimo. So more concretely, we need support for pluggable connectors. We need support for pluggable functions. We need consistent function evaluation across the coordinator and the worker. They can't be executing different functions, or they can't be trying to execute a function that only exists in C++ or vice versa. We need fast failures for things which are not going to work in Velox. And we need configuration knobs which are specific to the environment. So we need a list which is specific to whether or not I'm deploying a C++ or Java cluster, because we need to document what takes into effect when you set a session property. So this is kind of like the general idea. It's just kind of like for illustration purposes, it's just kind of like what we would like to accomplish. Instead of having one directional communication where the coordinator dictates something that could be wrong, we want two directional communication where the coordinator is informed of whether or not it can generate a correct task based off of the capabilities of the worker. And here is where we get information on what functions do I have, what types do I support, what connectors, how can I use the metadata from connectors. So concretely, what are we planning? I wrote an RFC. It's RFC3. You can find it in the RFC's repo. The idea is you introduce a coordinator plugin, which only contains extension points for the coordinator with native clusters. The coordinator plugin consists of things like types customization and functions customization, things that you can do already, but which will integrate, will have knowledge of what actually exists on the native worker, and also some new things, such as how to optimize an expression, how to check, check if a plan can get executed, translate the plan to a Velox plan so that you can send it back as a part of a show plan, and what are the correct set of session properties that can be toggled by the user. And to support all these things, a new process type, which is the Presto Sidecar, is added, which communicates with the coordinator. The process type can be a Presto worker, or it can be a standalone process. It's up to the user to configure that. So we'll talk about some of the customization points and what this means, like how what this accomplishes. I think the most trivial is the types customization. Types move slowly. People don't add too many types. So there's really you just need a kind of like an in-memory mapping to expose to the user that there are certain types that are not supported in the native execution engine, and if you attempt to use them, then you will fail. If you attempt to create a Presto table, then you will fail. You need to use a different tool to create that table. Presto has the ability to completely customize the functions that get cataloged and executed through the function namespace manager. The native function namespace manager will integrate with the Presto coordinator and basically kind of return the list of built-in functions that actually exist in Velox. So it will correct the function mapping so that you can't attempt to use a function that doesn't exist or a function that's registered for a different type. This calls the Presto Sidecar one time to just retrieve that list. You don't need the sidecar to do that, but it's convenient because you need it for other things. A big part of the consistency problem is, as I mentioned, there's just a lot of different, very subtle differences in function evaluation between Velox and Presto. And a lot of this is surfaced through the fuzzer testing. Some things that we will fix over time, but some things we'll never fix, as I mentioned. So what you really need to do is just use the C++ functions for expression optimization. Why do you need expression optimization? Well, primarily for constant folding. When you part of the job responsibility of the optimizer is to reduce the expressions that are being used to filter the tables or the expressions that are used within the query to their most simplest logical equivalent so that the worker has less to do. This is in particular particularly important when we use if the constant folding result can be used during the planning to filter out partitions. So if you have an expression that filters out to a constant and that's over a partition column, that's work that you cannot save through a worker-only approach. So there has to be a way to make it so that constant folding is consistent within the coordinator as it is in the worker. To solve this challenge, we have a native expression optimizer, which will simplify expressions in C++ and use the C++ functions to simplify the expressions so that you have consistent semantics between expression optimization and general eval. So I kind of didn't get into the timeline, but these things, types and function customization, we expect to finish this year. Expression optimization, I would expect to finish probably early next year. We're pretty far along with that. Connector support. I think this one is a relatively more complex topic, and I think requires a little bit more trade-offs. So let me try to explain the best I can. The problem with connectors is that there's a lot of legacy connectors out in the wild. There's the connectors that exist within the Presto repository, but then there's also custom connectors that we don't know about. And Presto connectors, really, you can think of them as a closed ecosystem. So it's Java specific, and it's also Presto specific. So you build a Presto connector, and you can't share it with anything else. It's really work that you do just for Presto. The idea is, what if you thought of connectors as an open ecosystem? So rather than thinking of connectors as a Presto-specific component, what if you had an API that could be used to describe how data is interchanged between services in a more neutral manner? And it turns out that Aeroflight and Aeroflight SQL at least partially solve some of this problem. You can do a lot of the work of porting a connector by basically kind of expressing it as an Aeroflight service. It doesn't solve completely the problem of how do all of the particular aspects of how to access data in that data source, how does Presto kind of use that information, but it does a lot of the work. And the idea is to use Aeroflight for remote connectors so that you can basically port your existing connector as an Aeroflight service. This would be for something which is not, can tolerate the latency hop, something where the majority of the work is being done on the remote system. You would not do this for something like Hive or Iceberg, where Presto is doing the majority of the work. But the idea is that if you do have a performance sensitive connector, you would probably want to rewrite the execution aspect in C++. But if you have a connector which can tolerate the latency hop, so you can think of a MySQL, Postgres, other types of data connectors that where the majority of the work is being done on the remote system, you could probably tolerate a latency hop, and you can export the connector code and create a shim so that the connector exposes itself as an Aeroflight service. So that's the idea for connectors. It's not complete. I'll get into that in a second, and I think I'm actually super over time, so let me try to wrap up as best as I can. There's a similar idea for functions where what we would want to do is think of functions as an open ecosystem. And you can choose to rewrite all of your functions as C++ functions. That could be a lot of work. We're developing a way to make it so that you can take your existing Presto Java functions and export them as a remote service so that you can execute them in Presto C++ clusters. And the thing that I think ties all these things together is that, how do I get all this capability without forking Prestissimo and without forking Presto? We're working on the ability to dynamically add functions and connectors via a shared library in C++ so that, similar to Java-based connectors, you can just drop in your shared library and customize the functions, types, and connectors in a Prestissimo cluster the same way that, in a very similar way that you can do with a Java-based cluster. I think, like the main idea, with some of this work is that we want to get to a place where native clusters have a lot of the functionality that you would expect from Presto, but not everything. If we try to port over everything, it'll probably be a lot more work than people have time for. But we think that there's a way to get to a good enough level of support where with the performance improvements that we see with Prestissimo and with a base level of support for functions and types and for connectors, we can get most of the way there and start to tell people that we prefer the C++ clusters for your deployments. We're actively discouraging the Java-based clusters. So we won't get to 100% compatibility with Java and C++, but we will provide tools like the sidecar that allow you to route queries and tell up front whether or not it's going to be successful in a Java cluster. And using that, you can route your workload. Finally, what will this mean for users? If you have an existing connector, is it performance sensitive? You want to build a C++ component so that you don't have to pay the performance hop, and you'll load that as a shared library. There will be instructions for you to do that, and an example makefile that shows how this works so that you can try it out yourself. If it's not performance sensitive, you could consider to use the shim, which exports the existing connector that you have as a flight service to provide that functionality without having to do a rewrite. Do you have an existing function? Is that performance sensitive? You'll want to rewrite that in C++. If it's not performance sensitive, you can use the REST server that will provide those scalar functions so that you don't have to do the rewrite. In all cases, you'll want to add the Presto Sidecar to your deployment. This could be as simple as checking a flag on one or more workers so that they can announce themselves as sidecars so that they can provide all the functionality to Presto, including the fail fast, including the expression optimization and the constant folding. You'll want to add the Presto Sidecar to your deployment. You'll want to determine, we'll eventually, I hope next year, we'll determine when we have hit an acceptable level of reliability, ease of administration, correctness, and really what this is about, functionality. After we've achieved those four goals, we'll be working towards what does that mean in terms of versioning Presto. We've announced 2.0. We're still working on that. That's a very large effort, but we want to kind of like have we want to mark this milestone with a major version bump of Presto due to its significance. And then after 2.0, or whatever we end up calling that, we will encourage folks to use C++ and encourage the community to consolidate around C++. And bugs reported on Java may receive a little bit less priority than they did before. We don't want to take that lightly, but we do want to get to a point where we feel that there is sufficient functionality in C++ that we feel comfortable doing that. That was a lot of talking. I'm open for any questions if there are any. I had to kind of like run through a lot of technical material, so if there's any questions, I'd love to talk about it. And I know it's lunchtime. So yeah.
So you are saying you will just play C++ function with Java-based function if this is like existing, for example, Java function through this REST server interface, correct? And it's separate from sidecar, or does sidecar include this REST server?
It's a great question. The sidecar is a C++ based process. So its purpose is to, kind of like bring, consistency to our Java-based coordinator.
Separate service. And is it going to run on every worker, or is it like this
It's up to you. We will provide Helm charts that kind of like demonstrate how to, you could do it co-located. There's obviously going to be a hit there because there's an overhead to just running any JVM. There's like a few hundred megabytes at least of memory, and that'll have its own overhead. You could choose to do it that way, or you could have, like, let's say, an auto-scaled cluster of independent scalar functions.
And just a quick follow-up. So basically, from worker, you will say, hey, this is function, this is piece of data. Please go and execute. Yes, REST server will kind of execute particular Java function on this piece of data, or how will it work?
The C++ worker will send over a page of data in the Presto page format. The REST-based server will execute that scalar function over that page of data and then return it back. So it's obviously not as efficient as doing everything in memory, but like we're not calling it row by row or anything crazy like that.
So you just give page and ask to execute function on this page. Okay. Thank you.
Which you can do now. What we're doing is we're providing a standard API.
Yes,
Yep.
Sidecar is a Java process or C++?
It's a C++ process. It may be a Presto it may be a C++ worker, or it could be an independent process. It depends on the needs in your deployment.
So when the final deployment is happening, there will be a Java coordinator and worker. Along with that, there will be a C++ process, which is the sidecar, or everything will be a C++ based deployment.
The Java coordinator remains in Java. The worker will be C++. The worker may also be a sidecar, or you could also co-locate the sidecar with the coordinator. Any other questions?
I have one question.
Sure.
So in today's implementation of the connectors in Prestissimo Velox, there are certain primitives that need to be serialized between the coordinator and workers, usually things necessary for executing splits for each query. Right now, we don't have like a very good way of kind of splitting out that information.
Yep.
Keeping the connectors separate, like outside of Velox. I know you said that there's plans to, do library loading, but one thing that will need to be shared between coordinator and C++ workers are these common serialized structures that contain like the metadata for executing queries. Has there been thought about how we're going to like be able to write because right now I think we do this weird like parsing of Java classes to generate the serialized objects in C++.
Yeah, that's a great question. So, what we do right now is basically we kind of like, make a big presumption inside of the Prestissimo code, which is that, the things that I know about are the connectors that I know about are the data structures that I know how to deserialize. And so that obviously doesn't hold with a custom connector. Let's say you fork Prestissimo and you add your own connector, you have to make Java side changes as well. So it makes it very, very cumbersome to have a dynamically loaded connector that doesn't require a fork, which is very, very expensive for folks. So this is actually discussed in RFC 3. I think there's a few ways to skin this, but the way that, kind of like we talked about in that RFC is you schematize those data structures so that when you do the work of splitting out the connector metadata from the worker, the execution aspects of the connector, you serialize those data structures that get shipped to the worker using a schema. So these are things like the table handle, the split. There's a couple other things. It's not a huge list, but essentially you say, here is a common way that I'm going to serialize this information, and this thing that I am sending this worker to, I know that it can read it, and I have a mapping from the coordinator to the worker that basically tells it how to, what's the schema of that data. So that has not been started, but we would like to do that work, and I'm hoping that we can get to that next year. I think the floor is yours.
So you are saying integration with kind of not C++ connectors will be through this arrow SQL, correct?
That is a way that we can provide. There's obviously like you can, but like we want, I think that the arrow-based approach is a good open source approach because Arrow has, especially Aeroflight SQL, has growing adoption. And so like this looks to be like a promising API to transport this information.
Yeah, but also like this arrow SQL is baked by another company, yes, kind of. And right now Presto is like everything is written from scratch. Right? We don't have like any big dependencies on others kind of parts, yes. But if we are saying arrow SQL, we will rely on arrow SQL to do this kind of integration. Yeah, this is only this part.
Yeah, we're not baking Arrow into Presto. What we're doing is we're creating a plugin inside of Presto that speaks Arrow and encouraging a specific, kind of like, format to migrate your connector. But there's nothing built into the Presto runtime or execution engines that's like, 100% Arrow specific. That'll be decoupled, as any connector will be decoupled. Yeah, the way that it'll work is like in the plugin layer, like we'll generate an Aeroflight, split, and then like we'll do the opposite of that in the worker. This is all kind of like in the plugin layer, and there's kind of like another layer within the flight service that translates the data of that flight ticket into something that it basically can be translated to a split for data fetching. All right, well, if there's no other questions, it's near and dear to my heart. If you'd like to come and talk to me about it, I'd love to talk about it with you. Lot of work going on, made a lot of progress. But there's still a lot, but I thought it was important to just kind of like talk about, like how we think that, basically this should move in the open source community. So if you're interested, definitely come and reach out to me and let's have a chat.